In this video, I'm going to solve this transportation mode selection problem. We have three choices: rail, truck, and air, with their specific rates, transit times, and shipment quantities. Total quantity to be shipped is 1.2 million pounds. Each pound worth $25, and inventory holding rate is 30% per year. Right. So as we discussed in the class, there are four different cost components here. The first one is the transportation cost. That is basically the rate per pound times the demand. Then we have in-transit inventory cost, and that is I times C times D times T. T is in days, so I'm gonna divide, and the I is in years. To make them time consistent, I'm gonna divide by 365. So for the rail, 25 divided by 365 will tell me what portion of the year this product was on the move with the rail transportation. Then we have inventory cost at source or shipping facility. That is I times C times AIL, as we know. And if the AIL is not known directly, we can do this calculation. Right. Then inventory cost at destination. That is, again, this time the formula is the same, but I'm gonna denote C with the C prime, as we discussed in the classroom. When you ship a $100 product across the, let's say nation, the product cost is not anymore $100, it is 100 plus the shipping cost, right? I'm just going to keep writing similar formulas for these two. Again, when I'm calculating these, I'm gonna use for the source inventory AIL at the source, AIL at the destination, if there is any difference between them, right? So let's start with the rail transportation. Transportation cost is R times D. That is 11 cents multiplied by 1.2 million pounds. And that turns out to be $132,000. Next, in-transit inventory cost. I times C times D times T divided by 365, right? And that is 0.3 times C is $25 times demand is 1.2 million pound times T for the rail is 25 days divided by 365, and that turns out to be $616,438 and some change, right? Next, let's do the inventory cost at the source. That is basically I times C times AIL, and I times C times Q over 2 plus safety stock. In this question, I'm not given the AIL information, so I need to go through the regular AIL calculation. But when I look into the information given, there is no safety stock information, so I could assume that is a 0. Or you could also assume that it's a fixed number across all modes of transportation, so everybody's cost will change the same amount, so it's not really a factor. So in this case, I is 0.3, C is 25. If you ship with the rail, you ship 100,000 pounds plus 0, but I'm not going to write that one again ever. And that cost is 375,000. And finally, inventory cost at destination, and for that it is I times C prime, and I'm gonna just go through and write this second formula, right? And see where C prime is C plus R, right? So 0.3 times 25 plus 11 cents of shipping rate with the train, and then 100,000 divided by 2. And that cost turns out to be 376,650. So the impact of transportation cost or rate on inventory is, in this case, this difference between 376,650 and 375,000. So by it's paying 11 cents for the rate, in a year you incur additional $1,650 cost, inventory cost. So the total cost of rail basically is sum of all these numbers, 132,000 plus 616,438 and 36 plus 375,000 plus 376,650. So total cost of rail is equal to 1.5 million $88.36. So in 1 year, if I use rail, the total cost is gonna be $1.5 million, and only 132,000 of that is actually shipping. The rest is inventory impact of that choice. Next, let's go do truck. Similarly, transportation cost is R times D, and that is for the truck, the rate is 20 cents, and then I'm shipping again this 1.2 million pounds, or I should, yeah, let's write it here. So $240,000. In transit inventory cost, ICDT divided by 365, right? And that is 0.3 times 25 times D is, in this case, again 1.2 million pound. Truck takes only 13 days to ship this item or deliver this item, and I'm gonna divide by 365, and that is basically equal to $320,000, $547.95. Inventory cost at origin or source, again IC Q over 2 plus safety stock, and I'm assuming safety stock is 0 because there is no information on that one. So 0.3 times 25. Shipment quantity, if I do ship with the truck, is 40,000 pounds, right? And then I divide by 2, ended up with $150,000. Next is inventory cost at destination. This time formula is I times C prime times Q over 2 plus safety stock. Again, remember safety stock is 0, where C prime is C plus R, that is 25 plus this 0.2, C prime is $25.2, right? So write it here, 0.3 times 25.2 times 40,000 divided by 2. And the total cost in this case is $151,200. Right? So again, total cost this time truck is equal to 240,000. That is the transportation cost, plus 320,547 and $95 plus 150,000 plus $151,200, and that is equal to $861,747.95. Right. So apparently truck is almost half the cost of rail, although you pay less amount for the transportation cost when you use the rail transportation, right? Final one is this air transportation, right? First let me do this. Okay, transportation cost. Again, it is R times D. The rate for air is 88 cents and 1.2 million pounds. That is equal to over $1 million transportation cost. Well, at this point, I know that, the truck is the lowest or cheapest option with 860,000, but I'm gonna just complete the rest of the calculations to get the full consideration, right? At least have an idea between air and rail, right? In transit, inventory cost, ICDT divided by 365.3 times 25 times 1.2 million times air takes only a single day divided by 365. So the cost is equal to, the in-transit inventory cost is equal to $24,657.53. Right? Inventory cost at source. Again, it is ICQ/2 plus safety stock. There is no safety stock information. I'm going to eliminate that. I is 0.3. C is $25, and if I use the air transportation, the shipment quantity is 16,000, and I'm gonna divide that one by 2, and this time the cost is inventory cost at the source facility is only $60,000, and then inventory cost at destination, right? First, I'm gonna define the C prime, that is 25 plus 0.88, that is 2588. So now this inventory cost at the destination is equal to I is 0.3, 2588, 16,000 divided by 2, which brings my inventory holding cost at the destination to $62,112, right, dollars. So the total cost air is equal to $1,056,000 plus $24,657.53 plus 60,000 and 62,112, which brings the total to $202,769.53, right? So overall, when I compare the cost, the rail was just over $1.5 million, air is just over $1.2 million, and the truck was $861 or $62,000 approximately. So I should choose the truck transportation for this example.